Hello guys, in this video I am going to explain you about the maximum power transfer theorem with the help of this circuit, and this is question number 46 of book Engineering Circuit Analysis by Hayt, Kemmerly and Durbin, and chapter number is 5. So the problem is that it is saying that for a simple circuit of figure this, graph the power dissipated by the resistor R as a function of R by S if R is varying from 0 to 3000. So to solve this question, first of all we need to write the expression for the power that is dissipating through this R. So to get the power, we know that power formula is simply I square R, right? So now first of all I need to determine the I the current flowing through resistor R. So from this applying the KVL, so we will write I is equals to 12 upon 1k. 1k is 1000, like this is RS is 1000, or let me write this as RS right now, RS plus R. So the plus R. So this is our I. Now substituting this value of I in this expression, I will get P is equals to 12 upon RS plus R square into R. Now the question is saying that we need to draw a graph. We need to draw a graph for the power dissipated by resistor R as a function of R by S. Means we need to convert this expression, we need to re-express this expression so that we have this term R by S. So for this, what we can do, I can, like the denominator, this denominator, I can multiply and divide it with RS. So multiplying and dividing it by RS, like simply if I take this, or P is equals to 12, and now if I multiply it with RS and divide by RS, so solving this, what I am going to get, I will get 144 upon, now this RS, I can take out this RS out of the square bracket, so it will become RS square because we have a square term over here. And in the remaining part, this part we can write it as RS upon RS plus R upon RS, right? And this is square, so it means it will be 144, it is 12 because still it is inside the bracket. So now I can write this as P is equals to this 12 as 144 upon this RS by RS, it will be 1 plus R upon RS ka whole square up into R upon RS square, right? RS square. Now since we need to plot a graph between P and R by RS, right? And we know that the value of RS, it is 1000 ohm. It is given in the question. Over here. So what we can do, we can let R by RS, let it be A, right? So means, let me write it in a bold, let A is equals to R by RS. Substituting this R by RS as A, our P, it will become 144 upon 1 plus A square into A upon, like this R by RS, this R by RS, it can be written as R by RS into 1 upon RS, right? So it is 1 by A into 1 upon RS, right? So sorry, it will be A upon RS, right? A upon RS. So I write it over here, right? Now RS is a constant. It is 1000. It is 1000. So simply our power expression, it will become 144 upon 1000 into A upon 1 plus A square, where A is equals to R upon RS, right? This. So now once we get this expression, now we need to plot it on a graph. If you plot this particular on a graph, like as the question is saying, once again, the question is saying that we need to graph a power dissipated by the resistor R as a function of R by S for this range 0 to 3000. So if you plot a graph, like if we have, like mathematically, if we have any function like x upon 1 plus x square, so the graph for this, mathematically the graph for this, for the positive range, it is something like this. It is something like this, okay, x, and this is 1, right? This is 1 by 2. So over here in our case we have, like it is, the graph is for this. Now in our case we have P. So to graph a P, to plot a graph for P similar to this, we will be having a graph like this. This will be our P. This will be our P. This will be our A, and our graph, it will be again, and this one, like in this case it is 1 by 2, but over here in this expression we have 1 over here, but in our case we have 144 upon 1000, means 0.144. so since when it is 1, it becomes half, so when we have this, it becomes half, so this will be 144 upon 2000, or simply we can write 72. We can write 72 upon 1000, right? So let me place it as 72 upon 1000. So this is the graph, and this A I can put, instead of A I can put R by RS. So this is the graph for our P versus R by S. Now what is this peak? Now if we look at this general graph, what we have plotted for x upon 1 plus x square, this peak will appear at 1. So over here also, like this, it is 1. 1 means that because on the x-axis we have R by S, so it means R by RS is equals to 1. So at R by S equals to 1, we have a maximum power which is equals to, we have maximum power P max, which is equals to 72 upon 1000 watt, right? So this is what we get from the graph, right? And it means this particular expression can be written as R is equals to RS. So it means that from the graph we can determine that we are getting a maximum power when R is equals to RS. So this is answer to the first part of the question. So let's check the second part. Now over here the range is 0 to 3000, right? So for 0 to 3000, like if I want to place, like R is 0 to R is 0 to 3000, right? RS is 1000. It means the range we need to plot R by RS range. It will be from 0 to 3000 upon 1000, means 0 to 3. So just somehow we need to plot till this point. But if we move to infinity, then it is going to be 0, right? So this is the first part. Now coming to the second part of the question, it says that graph the first derivative of the power versus R by RS. Means the expression of the power that we obtained, that expression we need to get the first derivative of that. And then we need to verify that the maximum power is transferred to R when it is equal to RS. Now what it means, because like as per the mathematics, we know that suppose if we have a graph, like suppose if we have a graph like this, right? And this is y, this is x. And now if we differentiate this curve, like if whatever is the equation of this curve, if we differentiate it, if we take a first derivative of this curve and equate it to 0, right? So with this we will be able to get the value of x. With this we will be able to, once we equate it to 0, we will be able to get the value of x, and that value of x will give us the location where y is maximum, right? So the purpose of the second part of the question is to determine the location of x graphically and also by numerically. So let's check how it is going to work. So we need to take the first derivative of the power. So the power expression we obtained is this one, is this. So let me write it again. P equals to 144 upon 1000 bracket a upon 1 plus a square, right? You can check. Yes, it is the same expression. Now if I take the dp by dA, I need to take the first derivative of this. So we know that if we have this type of a term where we need to take the derivative of u by v, then the expression is that we will keep v as it is and we take du by dx minus u dv by dx upon v square. So in the same way we apply the same thing for this expression. Over here we know that our u, comparing this a 1 plus a square with this, we get that our u it is a, our v it is 1 plus a square, right? So following this concept we will get like v we keep as it is, then derivative of u with respect to a we will get 1 minus u as it is, and then derivative of 1 plus a square we will get 2a upon v square. So 1 plus a square the whole square. So solving this we will get 1 plus a square minus 2a square. One minus a square upon 1 plus a square, 1 plus a square the whole square, right? 1 plus a square the whole square. And now for this one if you plot a graph, like let me show you. If you plot a graph of graph of 1 plus x squared divided by 1 plus x square square. So Google is going to give us the graph for this. So you can see the graph for this particular case, for this type of signal, it is this type, where at 0 it is 1, it is maximum at 0, right? So plotting a graph similar to this, we will get over here the graph between dp by dA, and this is A. Our graph, it will be something like this, right? And this is 1, right? This is 1 if we have this, right? But over here we have missed one thing, that we have this expression also, right? So this expression will also come along with this. So this is, we are going to place over here. So it means that our expression over here, it is not 1, it is 144 upon 1000. So it means it will not be 1, it will be over here, the peak value will be 144 upon 1000, right? 144 upon 1000. So we are getting the peak value at 0, right? We are getting a peak value at 0. So it means that when dp by dA is equals to 0, when dp by dA is equals to 0, we are getting a maximum power. Power is maximum, and it is equal to 144 upon 1000, right? So it means since dp by dA is equals to 0, at maximum power dp by dA is equals to 0, it means that I will, like, this is my dp by dA. So now if I substitute, if I equate this as equal to 0, so what I will get 144 upon 1000, 1 minus a square upon 1 plus a square whole square equal to 0, right? Now in the numerator, to make this equation as 0, so this numerator term 1 minus a square, it will be 0, because 144 is a constant, 1000 is a constant. This denominator should not be the constant, if it should not be 0. If it becomes 0, then this value becomes infinity. So the only possible way to make this as 0 is to somehow make 1 minus a square equals to 0. So from this we can come that a square is equals to 1. So a is equals to plus minus 1. So what is our a? Our a is r by rs. Since a is equals to r by rs, so it is plus minus 1. So from this we get r is equals to plus minus rs, right? So since resistance cannot be negative, so it means r is equals to rs. So with this we come to the conclusion that we will get a maximum power only when r is equals to rs. This we have proved with a p versus, with this graph also, p versus r by s, where we get the maximum, we get a maximum at 1, and from here also we were able to get r is equals to r. So the second part of the question, we have done the second part, which says graph the first derivative of the power versus r by s. So we have done this, and then it is saying that verify that maximum power is transferred to r when it is equals to rs. So this also we have derived, that maximum power will be transferred to this register, maximum power will be transferred to this register only where R is equals to Rs, right? And this is what the statement of the maximum power transfer theorem, that to transfer the maximum power to the load register should be equal to the internal resistance of the circuit. Internal resistance over here, it is Rs. So with this I complete this solution. So if you have any doubt, you can put it in a comment box. Do subscribe my channel and share this video with your friends and colleagues. Thank you.